Okay, guys, so today we are translating line segments. So we're going to be taking line segments and moving them all around. So we have our little graph here and some information. So let's read what it says. Number 1 says that Pedro's house is located at 610. I want you guys to graph the location and label its point P. So Pedro's house should be somewhere, it looks like these are counting by 2s. So 2, 4, 6. And up is counting by 2s. So 2, 4, 6, 8, 10. So we should be right here.
That kind of was not me.
Okay. And then it says that Jethro's house is located at 2, 3. Graph the location and label it point J. So do that for me really quick. So we're counting by 2s, guys, so we're going to go right 2, but if up and down I'm counting by 2s, where would 3 be located? In the middle between 2 and 4, right? And label that J. Draw a line connecting the two houses to create a segment PJ. Easy so far, right? So then part 4. I want you to determine the length of line segment PJ. So what are you going to use? You can use Pythagorean theorem, or you can use what we've been using, which is distance formula. So with your groups right now, use the distance formula to find PJ, and I'll write down the coordinates for you. P is at 610, and J is at 2, 3.
Is Pythagorean theorem the same as the distance?
So when we plug stuff into the distance formula, what point did you guys use first? 6 minus 2. Okay, so D equals the square root of 6 minus 2 squared plus, so then which order did you put them in the next time? Good, 10 minus 3 squared. Okay, what does 6 minus 2 give me? 4 squared plus 7 squared. So D equals, 4 squared is plus what? Okay. And that all comes out to the square root of 65. We actually just did this. What did the square root of 65 come out to? Approximately 8.1. Good. Okay, any problems with that? Okay, so we've talked about transformations a little bit in chapter, oh my gosh, you guys even remember? It was like chapter 5? 3 or 5, I can't remember. The official definition is the mapping or movement of all points of a figure in a plane according to a common operation. Meaning we take every single point on the line and we add 5. And then the whole thing moves up 5. Okay, so that's a transformation. We're moving the object around. There are specific types of transformations, and we've only been working with these so far, but I'm giving them a name now. They are called rigid motions. Rigid motion is a transformation of points in space, meaning we're just moving it around. Okay, so rigid motion means we're just moving it around. So under the umbrella of transformations, there is a specific type of transformation called a translation. A translation is a rigid motion that slides each point of a figure the same distance and direction. And then we had 2 types. We had horizontal translations. So sliding a figure left or right is a horizontal translation because we're moving it side to side. And sliding it up or down is a vertical translation because we're moving it up and down. We actually we've worked with these before. The new figure created from the translation is called the image. The original figure is called the pre-image. So pre-image is what you start with, the image is what you end with. Okay? And then let's look at number 5. Number 5 says line segment PJ is horizontally translated 10 units to the left. So what I want you guys to do right now in part A, graph the new location of line segment PJ. Label the new points. P, this little line on top of the P is called a prime. So that little tick mark at the top is a prime, meaning it's the same name, but we moved it. So it's a new point it's a new location of the same point. So P prime and J prime. Okay, so I'll do this one with you guys, and then I'll have you finish the other ones on your own. So we're going 10 units to the left. So flip it back over. So that means we need to take point P and move it 10 units to the left. So you're just going to count. 1, 2, 3. Oh, no, wait, these go by twos, right? 2, 4, 6, 8, 10. Put a point there and label it P prime. And then you're going to do the same thing with point J. So you're going to go 2, 4, 6, 8, 10. Don't move it anywhere else, just 10 units to the left. And you're going to label that J prime.
So it would be,
And so the next question asks us, part B wants to know, what are the coordinates of P prime and J prime? So guys, take a look at P prime and J prime. What are the coordinates of P prime?
-4.
-4, positive 10. And what about J prime?
-8.
-8, positive 3. Because it didn't move up or down, right? It just moved to the left. So let's write that. So in the next part B, P prime was -4, positive 10. And J prime was -8, positive 3. So really quickly, what do you notice? When we moved the coordinates to the left, what changed? The X's or the Y's? Just the X's, because we're moving it side to side. Okay? So the Y stayed the same. So what I want you guys to do is number 6 and 7. So now we're going from P prime, J prime, so the orange one that I just made, and I'm translating it 14 units down. Okay, so we're vertically translating 14 units down. So you're going to do the same thing, but this time you're counting down 14. Make sure you count by 2. Give me the coordinates of P, what we call double prime, and J double prime, because we have to name it something different. And then do number 7 with your group members as well. So then you're going to take P double prime, J double prime, and you're going to translate it 10 units to the right. Okay? Okay, guys, so we were taking P prime, J prime, and translating it 14 units down. So you're still counting by twos, so let's start with P. So we're going to go down 2, 4, 6, 8, 10, 12, 14, and you're going to put your point there and label that P double prime. And the next one is actually the tricky part because J prime is in the middle. So we're still going to keep the point in the middle, but we're counting by twos. So this is going to be 2, 4, 6, 8, 10, 12, 14. So it should end up still in the middle, in between, it looks like -10 and -12. And that's J double prime. Okay. So let's take a look at part B. What are the coordinates of P double prime? If you look at what we just graphed, what were the coordinates of P double prime? -4, -4. And what were the coordinates of J double prime? -8. And then look at the Y, where is it? Negative what? 11. Okay? Because it was between -10 and -12. So what are you guys noticing? When I moved PJ to the left, my Y coordinates stayed the same and my X's changed. Then I took from P prime, J prime, I moved it down. Did the X's change or did they stay the same? Did the Y's change? How did they change? I went from 10 to -4, -14. And then I went from 3 to -11. How did that change? -14, okay? So we're just moving it down. So then number 7 says we're going to take P double prime, J double prime, so the green one, we're going to horizontally translate it. So does that mean I'm going side to side or up and down? side to side, and it's 10 units to the right. So is that going to affect my x's or my y's? Your x's. So part A wants us to, without graphing, predict the coordinates. So this is P triple prime. So if I'm moving -4, 4, 10 units to the right, what do you think my new coordinate will be? If I'm going to the right, will I be adding or subtracting? Adding. So this would be -4 plus 10, which comes out to? -4 plus 10. 6. Does the y change? No, because we're moving it to the right, so it's going to stay as a -4. So do J double prime or triple prime for me really quick.
So you just add 10.
Mm-hmm.
But what if it's going to the left?
Mm-hmm. So what did you guys get for J double prime? Triple prime, sorry. 2 what? -11. So Dana said if we're going to the right, do we just add 10? Yeah. So if we're going to the left, what would we do? If we're going up, what would we do? Add, and if we're going down, we would subtract. Okay, so graph those really quick to make sure that we're right. So we're going 10 units to the right. So from here, I'm going 2, 4, 6, 8, 10, and that's P triple prime. And the J is going 2, 4, 6, 8, 10, and that's J triple prime. So all we did was we took the same segment and we moved it left 10, down 14, right 10. So if I wanted to move it to its original location, then where would I go? Up for how many? 14, because we moved it down 14. Other question I want you guys to think about before we go. Did translating the segments change the length of the segment? No, because we're moving the entire thing. That's what rigid motion means. We're moving the exact same object just around in different places. So the size did not change. Okay?